Heat death. Let's start with the quiet one. The patient one. This is how most physicists think it actually ends. Not with fire. Not with a crash. With cooling. Right now, the universe is full of energy. Stars burn. Gas collapses. Things happen because heat flows from hot to cold. But here's the thing. That flow only works while there's a difference. Stars run out of fuel. The last ones flicker out in about 100 trillion years. Then there's nothing left to burn. Black holes slowly evaporate. The largest take 10 to the 100th power years to die. Write that number down. It's a 1 followed by 100 zeros. Eventually, even they are gone. What's left is a thin, cold soup of particles, spread so far apart they never touch. No heat difference anywhere. Nothing can happen ever again. Let that sink in. The universe doesn't explode. It just runs down. Like a clock, no one wins. Forever. But what if it doesn't end cold? Big rip. This one is violent. This one has a deadline. The culprit is dark energy. The thing pushing the universe apart faster and faster. Right now, it's gentle. Galaxies drift away slowly. But what if dark energy gets stronger over time? Then the expansion accelerates without limit. First, the galaxies are torn from each other. Then individual galaxies are shredded. Then solar systems unbind. Planets ripped from stars. Then the planets themselves come apart. Then atoms. Then the nucleus inside the atom. Space itself expanding faster than anything can hold together. Here's the unsettling part. There's a specific moment when it happens. Some models put it around 22 billion years from now. The last second would tear apart everything everywhere at once. Not a collapse. An infinite stretch. But what if the opposite happens instead? Big crunch. Run the expansion backwards. Imagine gravity finally wins. If there's enough matter, the expansion slows. Stops. Then reverses. Galaxies that spent billions of years flying apart start falling back. The universe contracts. It gets hotter, brighter, denser. Everything that ever existed funnels back toward a single point. The cosmic background heats up. The sky turns to fire. Then all of space collapses into a singularity. The same kind of point it came from. Here's the strange beauty of it. The end looks exactly like the beginning. And here's the question that follows. What if the beginning happens again? Big bounce. Maybe the crunch isn't the end. Maybe it's a doorway. In this idea, the universe collapses, hits maximum density, and bounces. A new expansion begins. A new universe is born from the corpse of the old one. This could have happened before. Many times. We might be one bounce in an endless cycle. Here's what should bother you. If it's a cycle, nothing is truly permanent. Not this universe. Not the last one. Not the next. Just expansion, collapse, repeat. Forever in both directions. No first. No last. But not every theory is this tidy. Vacuum decay. This is the scariest one. Because it could start right now. Empty space isn't truly empty. It sits at a certain energy level. We assume it's the lowest possible. The stable one. But what if it isn't? What if there's a lower energy state waiting? Then somewhere by random chance, a tiny bubble of true vacuum forms. Inside that bubble, the laws of physics are different. Atoms can't exist. And the bubble expands. At the speed of light. Here's the genuinely terrifying part. You would never see it coming. It moves as fast as the light that would warn you. The bubble could already exist. Light years away. Headed here. And we'd have no idea until the instant everything we are stops being possible. No pain. No warning. Just an edge moving through the dark. But maybe physics breaks in a slower way. Cosmic heat versus cold. Here's a fact that ties them together. Two of these endings are about temperature. Heat death is total cold. Big crunch is total fire. The universe is balanced between them right now. And which way it falls depends on numbers we still can't measure precisely. The density of matter. The behavior of dark energy. We are living inside the question, not the answer. Let that sit for a moment. We don't actually know how it ends. But there's one more way out. False stability. Here's the twist nobody likes. Some of these could be happening already, and we just can't tell. Dark energy might be strengthening so slowly we can't detect the trend yet. The vacuum might be metastable, counting down on a clock we can't read. The honest answer is uncertainty. Every model fits the data we have. Each predicts a completely different death. Here's the part that should genuinely bother you. The universe doesn't owe us a clean ending. It doesn't care which story we prefer. It will end the way physics dictates, indifferent to whether anyone is left to witness it. The timeline. Let's put them in order. Vacuum decay could happen any second. The Big Rip, if real, lands around 22 billion years out. The Big Crunch depends on gravity winning, no fixed date. Heat death takes longest of all, past the point where numbers stop meaning anything. One of these is your universe's actual future. We just don't know which line we're standing on. But here's the final thought. The view from now. Every ending shares one feature. None of them include us. The Earth is gone in 5 billion years when the sun expands, long before any cosmic finale. So in a sense, the question is academic. We will never see how it ends. And yet we figured out the possibilities anyway. From a single planet, with brief lives. Looking up. That's the part worth keeping. The universe may not care how it dies, but for a small window of time, something inside it cared enough to ask. And that question outlived every star we'll ever see. Not bad. For stick figures on a rock,